Please confirm to me. All of you get my voice and screen. Those who are attending in online. Guys, please confirm to me. All of you get my voice and screen. Those who are attending in online. Am I audible, guys? Am I audible, guys? Please confirm to me. All of you get my voice and screen. Those who are attending in online. Guys, please confirm to me. All of you get my voice and screen. Those who are attending in online. Everybody, please respond to me. All of you get my voice and screen. Those who are attending in online. Right, sir. And check it what we completed in the last session. What topic here we are getting there. Is it okay? Is the screen is visible for you? No, it will come. Don't worry. Still, the problem is going. It is a dummy projector only, but it is not giving good visibility. రెండు కనెక్ట్ చేసావా చేసావా దీనికి స్ప్లిటర్ ఉంది కదా దాన్ని పెట్టాలి రెండు తెలుసా నీకు లైట్ తీసుకు వదిలేసి తర్వాత చూద్దాం రైట్ సార్ సో ఇన్ మల్టీ థ్రెడింగ్ ఆల్మోస్ట్ ఆల్ వి కంప్లీటెడ్ లైక్ వాట్ దేర్ thread safe resources part we are understanding. Thread safe resources part we are understanding. Inside this thread safe resources topic we understood like what use local variables over the class level variables and use immutable objects over the mutable objects. This data here we are understanding. Okay, right sir. So today we need to understand directly the synchronization topic. What topic here we have to understand there? The synchronization. This battery. Let's more bit. All right, sir. Synchronization topic here we have to understand. In that synchronization, okay. So what is this synchronization here? What we are understanding about synchronization? The process of allowing only one thread at a time, not allowing more than one thread at a time, allowing other threads after completion of the present thread execution. Come again, almost all the same point I have given there in 3 directions. Come again, what's the point I said? The process of allowing only one thread at a time, not allowing more than one thread at a time, and allowing other threads after completion of the present thread execution. After completion of the present thread execution is called synchronization. Right, sir. The synchronization is a mechanism which allows only one thread at a time, not allowing other threads at a time. Here, 1 minute. Right, sir. Coming. What I have to do here? Okay. Now it's coming. Double effect. Right, sir. Now just the process of allowing that. Before that, instead of saying the process here, what I am telling to you is a mechanism. Basically, synchronization is a mechanism synchronization is a mechanism right. Synchronization is a mechanism of allowing only one thread at a time, not allowing more than one thread at a time, and allowing other threads after completion of the present thread execution. Right, sir. Now this is exactly the meaning of like what there present thread execution is called as what there synchronization. Everybody understand it clearly. See, the point is here, the point is what is the point here I'm telling to you? 1 minute. Okay. Now here the point is what I am telling to you. In multi-threaded environment, we are going to send more than one thread to our program there. But when we send multiple threads at a time, where we should not allow all the threads at a time to our program, we have to allow only one thread. At a time. After completion of that thread execution only, another thread here we have to allow. So this mechanism is called as what? Synchronization. Got or not? All right, sir. But synchronization is going on or is implemented on the top of the locking mechanisms. On the top of what mechanism? Locking mechanisms. What is this locking mechanism? There's a question now. How this locking mechanism is implemented? And before that, I'm telling one more point here. You only tell me inside the synchronization, listen carefully. Inside the synchronization, how many threads are executing our code at a time? How many threads are executing our code at a time? Only one thread or more than one thread? Only one thread. At a time, only one thread is executing our code. Am I right or not? Remember carefully. Only one thread is executing at a time in the sense, is there any chance of getting data inconsistency? Is there any chance of getting data inconsistency? No chances of getting data inconsistency or not. So the synchronized resource is by default thread safe resource or not? Synchronized resource is by default thread safe resource or not? That's the point here we have to understand clearly. All right, sir. Now, in the case of synchronization, In the case of synchronization, at a time only one thread is executing or is accessing the data or is executing the code. At a time only one thread is executing the code. So there is no chance of getting data inconsistency. There is no chance of getting data inconsistency. Everybody understand my point here now? So by default, synchronized resources, by default, synchronized resources are thread safe. By default, synchronized resources are what they're thread safe. No need to have any second thought of it. No need to have any another explanation for this point here. How synchronized resources are thread safe by default. Only the point is what they're able to allow only one thread at a time to execute our code. Because of that reason here, synchronization is providing what their thread safety. By default, that resource is what their thread safe resource. Okay, fine. Next one is how the synchronization is going to be available. Understand it clearly? Now it is working, right? Fine, perfect. But do you expect what is going on in my mind there at least? At least are you expecting it? What is going on there? What I'm thinking now? Okay, it's not good thing to say outside now, right? But continue this now. Come this side. Those who are it is getting the problem there. Come this side now. No? What I have to do? Things are going on. Right, anyway, now let's move to the point here. In case of synchronization, at a time, only one thread is executing the code, so there is no chance of getting data inconsistency. By default, synchronized resources are what they're thread safe. By default, synchronized resources are what they're thread safe. And one more point I'm telling there, still I'm using workshop link only. If you want to check in mobile phones, we can open it and we can see the content. Right, sir. Then I don't have any alternative for it. One projector is running, it's okay. Okay, fine. Right, now let's move to the point here. In case of synchronization, at a time only one thread is executing the code, so there is no chance of getting data inconsistency. By default, synchronized resources are what they're thread safe here. Now observe carefully. In Java applications or in Java, synchronization is implemented. Synchronization is implemented on the basis of the logging mechanisms. Then what exactly the meaning of logging mechanism? How synchronization is going to be happen through this logging mechanism? We are going to understand it. Now let us see this point here. I want to take an example here. For this, now try to observe this. Now, for example, this is a code what we are having. This is a program. This is my code. Just we can understand it. This code is what there synchronized code only. Synchronized area. That means synchronized part only. Synchronized code. There I'm going to implement it. Now here 100 lines of code is available. For example, okay. Now when we are having these 100 lines of code, now what I'm telling now here we are going to have what we are able to have there, lock manager is existed here for the locking mechanism to control this total locking mechanism. Here there is a manager. That manager is what there, lock manager. Okay, this is about our code. Lock manager is existed here. When more than one thread is coming to this particular synchronized program, first of all threads will come toward their lock manager. This is thread 1. This is T1 thread. At the same time, next one is what there, T2 thread. This is second one, T2 thread. T2 thread. Then after this, what next one here we are able to provide T3 thread. Some other thread here we are going to take. Now tell me overall how many threads are created here? Three threads are created. All three threads we are submitted to the lock manager. Three threads we submitted to what there, lock manager. Understand it clearly. When three threads are coming to this lock manager, whenever three threads are coming to this lock manager, what is going to be happen here? Observe carefully. First of all, lock manager will follow some algorithm internally. It will give priority for one thread first. Understand my point here now? Then immediately what it will do, it will assign lock to one thread. Out of these multiple threads, it will assign lock to what there, one thread. Now this is the first thread. For T1 thread, it assign lock there. Now here we can understand now, log is assigned for T1 thread. How log is assigned to the T1 thread now, it has some internal mechanism. Now this time log is assigned to T1 thread. Log assigned to T1. When log is assigned to T1, now T1 thread is eligible to enter into the synchronized area. Now T1 thread is eligible to enter into what there, synchronized area. Now it has to execute the program. The total program it has to execute without having any breaks, without having any break. Continuously, the program must be executed. At the end of the synchronized code, at the end of the synchronized area, then what that thread 1 has to do there, thread 1 must assign, thread 1 must send that lock back to the, thread 1 must send that lock back to the, one minute. Thread 1 must send that lock back to the lock manager. This is what they're getting lock back from thread. All right, sir. Now sending lock to the lock manager. T1 thread, when it executed completely the synchronized area, then lock will be given back to the lock manager. Now this thread is completed. The thread will come to the dead state or maybe continuing the further execution. That's okay, fine. Then it will go with what there, further execution or terminating the thread, or maybe the thread will go to the dead state. That doesn't matter. But at the end of the synchronized area, which thread is completed its execution, that thread will submit that lock back to the what is going on here? Okay, good. So this is about like what there, one thread execution here. I'm getting there. Next one is after that, after completion of this, that another thread here I'm telling to you. Now see this one, when lock manager is getting lock, acquired lock from the thread 1, now it is ready to assign that lock to the next thread. Already in the waiting state, how many threads are available? 2 threads are available. One thread is under processing. 2 threads are available. Next lock This is another special effect. I think I'm not suitable for teaching, sir. Okay. All right, sir. Now come for it. Now another thing is like what there after this, log manager is ready to assign log for the another thread. In the queue, two threads are available. Then it will follow some algorithm internally. It will assign log to what there one of among two threads. One thread. It will assign log to the next thread. Now what thread is the next thread here? No, now observe carefully. Immediately it will give that thread to the, that means next, for example, if it gives priority for what the T2 thread, now T2 thread will get lock. Now this time T2 thread will get lock. Lock is assigned to T2 thread. Lock manager assign lock to what there T2 thread. When it assign lock to the T2 thread, when it assign lock to the T2 thread, what is going to be happen here? No, assign lock to T2 now. Then immediately that T2 thread is eligible to enter into the synchronized area or not. When a thread is getting locked, when a thread acquired lock from lock manager, the thread is eligible to execute the synchronized area. Now this instructions, it may take some time here. Executing this total program may take some time here, but overall this thing is going to be executed. When it is executed, when the synchronized area is executed, understand my point here? When it is executed, then what next one here? No, at the end of this execution, what it is going to be happen directly? Now that the T2 thread send back that log to what their lock manager. T2 thread will send that log back to what their lock manager. Yes, sir, got it or not? Now, okay, this is like what I'm telling to you, sending log to the lock manager. Sending log to what their lock manager. All right, sir. Now log is available with what their lock manager. Now, how many threads are in waiting state? No, only one thread is in waiting state. Definitely, it will give priority for what there the respective thread only. There automatically it will give priority to the next thread. That the thread will come into the picture. To that thread, our lock manager will assign the lock. Now, here, what is going to be happen here? Now, lock manager will assign a lock to the respective thread. Now, after that, then whenever the lock is assigned to a particular thread, assign log to T3 thread, assign log to T3 thread. When T3 thread acquired the lock, T3 thread is eligible to enter into what their synchronized area. Now it will execute the total synchronized area. How much time it will take to execute the total synchronized area? It will be executed. When it is executed at the end of the synchronized area, again what is going to be happen there? Immediately that thread will submit back that log to what their lock manager. Immediately that thread will send back that log to the lock manager. Now lock manager is waiting for some other thread which is coming into the synchronized area. If any other thread is coming into the synchronized area, immediately lock manager will assign that log to the next thread. Next thread will execute the content. Now, if it is a process there, now tell me at a time up to this synchronized area, how many threads are going to be executed? Only one thread is going to be executed. If it is only one thread, now tell me, is there any chance of getting data inconsistency? No, there is no chance of getting data inconsistency. So by default, all the synchronized resources are thread safe resources or not? By default, all the synchronized resources are what they're thread safe resources. Now this is a simple explanation about like what their logging mechanisms here we are getting. All right, so now I'll give that points also, few points here I'm going to specify there. In Java, synchronization is implemented on the basis of the logging mechanisms. Okay, fine. Now observe carefully, what is this locking mechanism? What is going to be happen there? in the case of locking mechanism, or maybe in the case of synchronization, if we send multiple threads to the synchronized area, if we send multiple threads to the synchronized area, synchronized area at a time, lock manager will keep all the threads in a queue, Mr. Got it or not? Or else no need to get any confusion in waiting state, simply speaking. How it is going to be maintained in waiting state? No, in the form of a queue only. Understand it clearly. In a queue, threads in waiting state. Okay. Lock manager will assign a lock. Lock manager will assign lock to a thread, which is having priority. That priority I'm not defining. On which factor that priority is going to be taken, it is an internal concept. Internal of like what there? Lock manager or inside the synchronization. Which thread will be selected, we don't know. Automatically it will be selected by following some algorithms internally. Okay, fine. Then lock manager will assign lock to a thread, lock thread which is having highest priority, Okay, once if any thread acquire lock from the lock manager, that thread eligible to execute the synchronized code. That thread is eligible to execute what their synchronized code. Once if any thread completes its execution in the synchronized area, then that thread will submit lock back to the lock manager. Okay, once the thread is completes its execution in the synchronized area, then the thread will submit lock back to the lock manager. Okay, where lock manager will assign lock to the next thread which is having highest priority. Which is having what their highest priority. But on what basis it is able to select the thread is total internal concept of the locking mechanism that we are not going to aware. Even though if we start 3 threads like what thread 1, thread 2, thread 3, but which thread will be taken by lock manager we don't know. One time execution will take the order like what thread 1, thread 2, thread 3. In the next attempt what it will take the order like what the thread 2, thread 3, thread 1. In the next attempt it will take the order like what the thread 2, thread 3, thread 1. But we don't know in which order is going to pick the thread. But once if it is pick the thread now, until the completion of the thread it will not allow the other threads. But pick up the thread is random. But once it is taken one thread now, until the completion of that thread it will not allow what their other threads now. So only here the point we have to recognize, is there any chance of getting interferences or not between the threads now? One thread is interfering another thread execution or not, that only we have to check. That means whether we are going to get mixed outputs or sequential outputs. Definitely in the case of synchronization, what outputs can we are able to get? No, sequential outputs only. We are not going to get what their mixed outputs can. No. Sir, all of you get my point or not? Then we may ask one question to me, sir, if it is a sequential output now, performance will be down. More execution time will be taken, performance will be down. Yes, definitely. The same, your thought is right. There is a drawback with synchronization. If you want to achieve data consistency, we have to implement synchronization. But if you want to implement synchronization, then we have to compromise about the performance. But there also be some solutions are available. What about the solutions? No, you are not going to keep the total program inside the synchronization. We are not going to keep the total program inside the synchronization. Where the sensitive code is available, in which code there is a chance of getting data inconsistency, up to the 2 lines of code or 3 lines of code or 5 lines of code, we are going to keep inside what their synchronization. Not suggestible to keep the total program inside the synchronization. I'll forget my point or not. In the case of try catch, finally I given one point. Entire program we are not going to keep inside the try block. Which code is a doubtful code where to get an exception, that code only we are going to keep inside what block there? Try block. Understand my point or not? Now here also the same point I am telling to you. Here also be what is going to be happen. We are not going to keep the total code inside the synchronization. As per the requirement only, we are going to keep our code inside the synchronization. Which code is a sensitive code, where there is a chance of getting data inconsistency? That code only we are going to keep inside like what there? Synchronization. Yes, sir. All of you are getting it or not? All right, sir. Now this is a clear-cut analysis about like what there, this synchronization content, then how that like what I'm telling there, mechanism, that logging mechanism is going to be happen internally. We understood that point here. Okay, fine. After this, after completion of this content here, the next one, observe carefully, all of you know, the next one is what there. Listen carefully. The next one is how many ways we are able to achieve synchronization. There are two ways to achieve synchronization. There are two ways to achieve synchronization. What are the two ways to achieve synchronization here? Now, first one is what there? Synchronization, synchronized methods, and the second one is what there? Synchronized blocks. Synchronized methods, and the next one is what there? Synchronized blocks. Now we have to understand what is the meaning of synchronized methods. What is this synchronized method? Right, so definition is very same. Previously, what we understood the definition for synchronization, the same definition here we are going to understand. Why? Because now it is a method. Right, sir. Now see this one, the same point here I'm telling you. Synchronization is a mechanism. Okay, synchronized method is a set of instructions, comma, it allows only one thread at a time, not allowing more than one thread at a time, and allowing other threads after completion of the present thread execution. Is it good or not? It is a set of instructions which allows only one thread at a time, not allowing multiple threads at a time. After executing the present thread, no, then only allowing what their other threads. So this instruction, this set of instructions, or this method is called as what their synchronized method. Right, sir. How we are going to provide this synchronized method? How we are going to provide this? If we declare any method with a synchronized keyword, then that method is a synchronized method. If we declare any method with a synchronized keyword, then that method is what there? A synchronized method. Right, so example I'm telling you now. See this one, synchronized keyword here we provided synchronized void m1 method. Here we have to provide like what there? Multiple instructions. Now whatever the instructions here we provided, automatically synchronization is going to be applied for all the instructions. Okay. And one more small note here I'm telling to you, when it is possible to achieve synchronization in our applications there, if you come for this point, in the case of concurrent threads only. In the case of what threads? No, concurrent threads. What is the meaning of concurrent thread? No. What is the meaning of concurrent threads? The meaning of concurrent threads is what? All right, sir. When more than one thread is acting on the same resource, then that process is called as what there? Concurrent threads. The threads are called as what there? Concurrent threads. No? The same point I'm telling there. So when we submit more than one thread on the same data item, when we submit more than one thread on the same data item, and when we submit more than one thread on the same data item, and when we execute more than one thread on the same, on the same code block, code block, then only we are able to apply synchronization. Then only we are able to apply what there synchronization. When we submit more than one thread on the same data item, and when we execute more than one thread on the same code block, then only we are able to apply what there synchronization. We are able to implement synchronization. All of you get my point or not? Yeah, the point is what there. If we submit more than one thread on the same data item, or if we execute more than one thread on the same code block, then only we are able to achieve what there synchronization. Right, sir? Now get. It's okay. That means if you want to implement synchronization, more than one thread must come to the same object. More than one thread must come to the same code block, same method or same code block. Then only we are able to achieve what there synchronization. All right, sir. That's okay, fine. Now I want to show an example on the basis of synchronization. Try to understand it. A simple code here we are going to understand about the synchronization. All right, sir. Observe carefully. All right, sir. It's okay. I want to create completely new project. So Java, IntelliJ IDEA, click on create. Right, sir. Now see this program, all of you know. First of all, I want to take multiple threads. Multiple threads here I want to prepare. Now, first of all, class thread 1 extends thread. And before this thread 1, I want to take class A, for example. Inside this class A, I want to take void m1 method. First of all, I want to show output without synchronization. Okay, then after that I will implement what their synchronized blocks, synchronized methods. This method I'm going to make it is what their synchronized method in the future. Now I want to take like what for loop int I is equal to 0, I less than 10, I plus plus. Then inside this sys not outed println of, here I need to provide thread dot current thread dot get name method here I want to call thread dot current thread dot get name method here we are calling. Right, sir? That's okay. Now here more than one thread I want to be submitted to what the same m1 method. So same reference value here we have to provide to all the threads. Now here this is like what their thread 1. Inside this thread 1 here we provided a small a. Now here we provided like what there this dot a is equal to a semicolon. This dot a is equal to a semicolon that we are getting. Class thread 1 extends the thread a small a is equal to thread 1 a small a this dot a is equal to a. Next one is what there run method. Inside this run method here we are using what there. Now a dot m1 method here we have to call. Now here we are providing what there m1 method call here. Thread 1 we submitted to what there a class a and m1 method. Then after this, after completion of this one, let me copy this. I want to take something else like what there another thread here I want to prepare second thread. So it should be like what there thread 2. Now constructor is also like what there thread 2. Okay. Now next one is what there a dot m1 method same. Similarly, I want to create like what there thread 3. Another class here I'm going to prepare. Now this class is like what there thread 3. Alright, sir. Now here we are providing like what there thread 3. Alright, sir. Now a dot m1 method. Alright, now here how many thread classes are available? 3 thread classes I prepared. In all thread classes we are calling what method now? M1 method. That means in all thread classes run method we are calling what there M1 method. Means that all 3 threads are coming to what M1 method. All 3 thread classes are coming to what there M1 method. Now okay, first of all let me create like what there all the thread a class objects A small a is equal to new a. Thread 1 is equal to new thread 1 of a. Next one is what there? Thread 2 is equal to new thread 2 of a. Next one is what there? Thread 3 is equal to new thread 3 of a. Now okay, we are getting like what there? All the thread objects. Whenever we are getting all the three thread objects now, I want to give names for all the three threads now. If I'm not providing any name now, by default it will take like what there. Now thread 0, thread 1, thread 2, like these values are coming there. But now I want to provide what there? Some names. Has I got it or not? Right, so then what names here we want to provide? Thread 1 dot set name. What names here we have to provide? Any name here we can provide. Say for example, thread 1. Next one is after that, thread 2 dot set name. Thread 2. Now thread 3 dot set name. Thread 3. Like overall, thread 1 dot set name, thread 2 dot set name, and thread 3 dot set name. After providing all the names to all the three threads, next one is I have to start all the three threads. Thread 1 dot start method, thread 2 dot start method. Next one is what there? Thread 3 dot start method. Even though we started one after another, but at a time all three threads will come to what there? Come to the respective M1 method, where lock manager will allow only one thread at a time by assigning a lock. Once the thread execution is completed inside the synchronization method, it will submit that lock back to the lock manager. Lock manager will assign that lock to what there? Some other thread. But anyway, in this example, I have not provided like what there? I have not provided synchronization. Without providing synchronization, we are trying to execute the program. Now let me check this. See this one, then what output here we are getting there? Is that mixed output or not? Definitely mixed output only. It seems like sequential output. No, it's a mixed output only. Execute one or two times here. There we are able to get output like what there? Mixed output. Right, sir. Now my laptops are a bit fast machine. That's why within a single might be a little time slot, the total thread is going to be executed now. But if we execute continuously, then we are able to get what there? Mixed output. Yeah, at least now here we are getting first one thread 2. Okay, thread 3, thread 1. Here thread 2 we are getting. Right. Continuously you can execute this 2 to 3 times. If we execute there we are able to get our required output. So mixed output here we are getting. Got it or not? If we execute the same program in edit plus, but perfectly mixed output there we are able to get it. Okay, right, sir. Let me check this one anyway, then I don't want to give any confusion. Now I want to execute the same program in edit plus here. Now observe carefully. Now I want to take a new file. I want to take this classes like what there, test class. Let me save it. Where we want to save this now, D drive full stack Java 10, full stack Java 10. There I want to provide what there, tester.java. All right, so now see this one, Java C space tester.java compiled successfully. Java space tester. Now we are getting like what output, mixed output. Just we can identify clearly the mixed output. Once again, if we execute this one, then perfectly mixed output here we are getting 1 1 2 3 2 1 1 2, like this here we are getting some mixed output. Perfectly we are getting like what the mixed output. All right, sir. But the point is what I'm telling to you here, I want to make this method as what? Synchronizer method. I want to make this method as what? Synchronizer method. If we declare this method as a synchronizer method, that's finished. Almost all that entire method execution is going on in a sequential. Once one thread is started, second thread will not interfere. But which thread will be selected as the first one, we don't know. It may be one thread out of 3 threads. It may be thread 3. It may be thread 2. It may be thread 1. But once one thread is started in the synchronization, other threads are not going to be allowed. This is exactly the meaning of like what their synchronization. Now see this one. In the output here we are able to get. Now we can take this output either in IDE or in like what there or in the edit plus anything whatever it may be. First thread 1. Next one is what, sir? Thread 3. Next one is what there? Thread 2. Run any number of times here. Execute any number of times. No. Now okay, this time what we are getting there, first thread 1. Next one is what there? Thread 2. Next one is what there? Thread 3. Now execute one more time. Now inside this, what output here we are getting there? Thread 1, thread 3, thread 2. Execute any number of times there, we are able to get output. Thread 1, thread 2, thread 3. Now we are getting sequential output or not? Right, so now this is an example for what there? This is an example for synchronized method. Example for what there? Synchronized method. Completed. Now here I want to give that output also clearly for this. Now try to right, sir. So total output here we are getting, understand it clearly. Next one is what there? After this, after completion of this program there, now we need to go for what there? Synchronized blocks. There we have to go with what there? Synchronized blocks. Next one. But before going to understand the synchronized blocks, I have a question. Before understanding synchronized blocks, I have a question. What about my question here? Understand it? No? 1 minute, sir. I have a question. What about my question here? To provide synchronization, already we have synchronized methods. Then what is the requirement? What is the requirement to use synchronized blocks? To provide synchronization, already we have synchronized methods. Then what is the requirement to use synchronized blocks? Answer is very clear. Now try to understand it. No, first of all, let me explain this part here. After that, we are going to understand it now. For example, here we are having here I have a program. So this is my program. Inside this program, how many lines of code is available? Maybe for example, 100 lines of code is available. Now I want to say this is like what their synchronized method. Synchronized void M1 method. Synchronized void M1 method. Open it. Now here we are going to close this. Synchronized void M1 method. These many methods are existed here. So number of instructions are available inside this M1 method. Say for example, 100 lines of code is available. Alright, sir. Now here overall 100 lines of code. Now tell me, if we provide synchronized method, then synchronization will be applied for all the instructions of this method or not? To provide synchronization, if we use synchronized method, then inside this synchronized method, whatever the code we have written, but the total code, the synchronization is going to be provided or not? Say for example, 100 lines of code is available, 100 instructions are available. Up to all 100 number of instructions, that synchronization is going to be applied or not? So 100 number of instructions are allowed by only one thread at a time or not? But actual requirement of the synchronization among these 100 lines of code is only 10 lines of code. 50th line to 60th line. 50th line to 60th line is the actual requirement of the synchronization. 50th line to 16th line is the actual requirement of the synchronization. But because of that reason, if you provide synchronized method, unnecessarily the total method, entire method is getting that synchronization or not. When the entire method is getting synchronization, entire method is allowing only one thread at a time or not. Unnecessarily synchronization if you provide there, only one thread at a time is executing, means that sequential execution is going to be happen, execution time will be increased, performance of the application will be reduced. So in this particular case, to improve the performance, we have to provide synchronization up to the required part. Don't provide synchronization throughout the method unnecessarily. Inside the method, which part is required synchronization really, provide synchronization up to that particular part. Don't provide synchronization throughout the method. All of you are getting it or not? So because of this reason, what I'm telling there, to provide synchronization up to the required method, instead of providing throughout the method, if you want to provide synchronization up to the required method, there we have to use synchronized block. There we have to use what there? Synchronized block. Now see this one. Now what is the point I'm telling there? I require synchronization now from this point to this line only. So here what we have to do there in this line now, there we can provide synchronized of this in the sense object to lock that we are going to provide. Synchronization is going to lock the current object. It will not allow what there other up to this particular part here. Understand it clearly? Okay, this keyword we are providing current class object here we have to provide. All right, after that open the brace here. Now here we have to close the brace. Whatever the intersections here we are getting there, after that intersections it is providing what there? Synchronization. This is exactly the location where synchronization is provided. Now tell me, if we send more than one thread at a time here to this particular line, what is going to be happen there? Now tell me. If we submit more than one thread to this program, multiple threads are coming for this program. Almost all 4 threads here we provided. Now what is going to be happen here? No, in the case of the synchronized method, if it is a synchronized method, out of this 4 thread, only one thread is allowed. All remaining threads must be in what their waiting state. But if it is synchronized method block now, all 3 threads at a time they're coming inside what they're coming inside the synchronized block. All 3 threads are coming, all 4 threads are coming to what their synchronized block at a time. Now here in this location. But when they're coming inside the method now directly, up to 50 number of intersections, multiple threads are executed or not? Up to 50 number of intersections, multiple threads are executed or not? Out of this 50 number of out of these 4 threads now, when it comes to the synchronized block, it allows only one thread execution at a time. It tells us how many thread execution here? Only one thread execution here. Once it is completed, again now multiple threads execution is going to be happen. Once the synchronized block execution is completed, multiple threads are going to be executed. Multiple threads are going to be executed. That's it. Now tell me, in a synchronized block, how many threads are executing at a time? Only one thread. Before synchronized block, multiple threads. After synchronized block, multiple threads are executed now. Now this approach will improve the performance of the applications or not? This approach will provide improvement in the program execution or not? So that's why always it is suggestible to provide synchronized blocks instead of what their synchronized methods. Why? Because synchronization is not a good concept. Synchronization will reduce the performance of the applications. Of course, it is able to provide data consistency, but for the sake of data consistency, we have to compromise about what their performance of the application. But if you are not thinking about the data consistency, then it is not at all suggestible to use what synchronization in our applications. It is not at all suggestible to use what their synchronization in our applications. Why it is not suggestible synchronization? No, I can give one example to you. Understand it now. For example, if it is a website application, website related application, say for example Facebook is an application, server side application only. In general, what is going to sorry in general, what is going to be happen inside the Facebook application now, at a time billions and billions of requests are coming to the Facebook application. If Facebook application is designed on the basis of synchronized methods topic or synchronization, what is going to be happen? For every request, a thread will be created. For every request, a separate thread will be created. Got my point or not? For every request, a separate thread will be created. Am I right or not? Whenever requests are created, whenever threads are created, that multiple threads are coming to a single location or not? Answer my point. That multiple threads are coming to a single method or not? Okay. If Facebook application is written on the basis of like what their synchronized method, when multiple requests are coming, multiple threads are coming, then it will keep all the threads in waiting state or not? It allows only one thread at a time or not? Means that it allows only one user to process that request or not? But at a time, how many users are available for a Facebook application? No. Let's say, for example, 1 lakh users are available at a time. You are the person offer 1 lakh users. Then whenever request is going to be processed, if it allows only one user at a time, if it processing only one request at a time, whenever turn will come there to process your request in the Facebook, no, maybe after 5 to 6 years of time, your token will come. So we'll use again that Facebook application, no? Yeah. So what is required in the case of Facebook application? Concurrent execution is required. What execution is required there? Concurrent execution is required. Parallel execution is required. Irrespective of the number of users, that program must be executed for each and every thread. For each and every request, for each and every user request, process must be provided, response must be provided. Then our users are going to use what their Facebook applications. So because of this kind of problems, nobody are going to use what their synchronization unnecessarily. If it is exact requirement, then only use it. Otherwise, don't use this one. Get my point or not? For example, previously I explained about ATM application, wife and husband and joint account. That example I provided there. Am I right or not? Right, sir. In the database, when multiple threads are coming there to perform their withdrawal operation, in the account only 10,000 is available. If both the transactions they want to withdraw 7,000 each, if we are allowing that both the transactions at a time, what is going to be happen there? 4,000 is the loss to the company or not? Loss to the bank or not? So there we need to apply synchronization for the transaction. If we apply synchronization, what is going to be happen? It allows only one transaction at a time, either wife or husband, whatever it may be. Once it is in process, no other thread is not going to be allowed. Other process is not going to be allowed until the completion of the present one. When it is completed present one, then when second one is trying to process there, when that second person is trying to withdraw 7,000, the bank application will send a message, no, the available balance in our account is only 4,000 or only 3,000, but you are not supposed to withdraw 7,000 rupees from this account. Then try to provide valid withdrawal amount. Like this, we are able to secure our applications. We are able to provide what their consistency in our applications. Right or not? So their synchronization is mandatory instead of thinking about what their performance. But without having any cause, without having any necessity, without having any reason, if you apply the synchronization, performance of the applications are going to be down. No chances of getting performance in our applications. Because of that reason, try to avoid the utilization of synchronization as much as possible. As much as possible, try to avoid the utilization of what their synchronization. Is that okay? All of you are getting clarity on these points now? Right, sir. Now this is exactly the meaning of what their synchronized method, synchronized block requirement. All right, sir. Now, let me paste this diagram here. Then after that, I want to give information to you. To provide synchronization in the Java applications, if we use to provide synchronization in the Java applications, if we use synchronized methods, then the synchronized method, will provide synchronization throughout the method, irrespective of the actual requirement. Throughout the method, irrespective of the actual requirement. Inside a method, if you need synchronization, up to a particular after a particular block of instructions, then we have to use synchronized block. Then we have to use synchronized block for the required block. We have to use synchronized block to provide synchronization to provide synchronization for the required block of instructions. So okay, now come again. What is the point I said to you? To provide synchronization in the Java applications, if we use synchronized method, then the synchronized method will provide synchronization throughout the method, irrespective of the actual requirement. It will reduce the application performance. Inside a method, if we need synchronization after a particular block of instructions, then we have to use synchronized block to provide synchronization for the required block of instructions. It will improve Java applications performance. Right, sir. Now this is the point here what I've given. Diagram is also be provided for this. There we have to use the diagram, but how we are going to implement the synchronized block there over the content, I want to show in the same example. I want to show that synchronized block content here. Try to understand it now. No need to go for any other example. In the same example, easily we can identify this. See this now, in the same program, I don't want to use that M1 method synchronized here. I want to remove this. There here, what I am going to provide in this case now, in this case, I want to provide the same instruction here. Next one is I'll provide synchronized this block. I want to provide block for synchronization. Synchronized block for this for loop. Now here what I will do here, before synchronization, then the details about this particular name of the thread here we provided. The same thing here we want to provide, but here we are going to write like what there inside the synchronization. Before synchronized block, now here inside the synchronized block, inside what there synchronized block, same thing I provided, no, but observe carefully what type of output we are expecting from this program. From this program we are expecting what type of output? No, our output value would be like what there before synchronized block thread 1, before synchronized block thread 2, before synchronized block thread 3. Once the thread 1 is entered inside the synchronized block, inside synchronized block thread 1 10 times, inside synchronized block thread 2 10 times, inside synchronized block thread 3 10 times. This output here we are expecting, or else whatever it may be, that final output I am telling to you. Once the thread 1 is entered into the synchronized block, until the completion of the thread 1 in the synchronized block, no other thread is going to be allowed. Understand my point here? In the middle of the inside synchronized thread 1, maybe before synchronized block thread 2 will come, before synchronized block thread 3 will come, but inside the synchronized block, once one thread is allowed, other threads are not going to be allowed inside the synchronized block. Just we have to put focus on inside synchronized block, how many threads are executing at a time. Inside the synchronized block, how many threads are executing at a time, that we have to focus. Okay, now let me execute this program here. If I execute this program, there we are able to get output like what? See this, what output here we are getting, sir? First 3 outputs are what? Before synchronized block thread 2, thread 3, thread 1. So I already said to you which thread that synchronization will pick, that its internal content. We are unable to predict it. Next one is what? Next one here we are getting there. Now check this. No, inside synchronized block, which thread? No, thread 2. Do you have any interferences in the middle of the thread 2? No, no other thread is interfere inside this what there thread 2 execution. Thread 2 is completed here. Next one is what there? Thread 1. Thread 1. Until the completion of the thread 1, is there any chance for thread 3 to interfere inside the thread 1 execution? No, thread 3 is not interfere in the thread 1 execution. It will not come in the middle. All right, after that only thread 3 is coming there. After that only thread 3 is coming. Yes, sir, got it or not? Right, so this is the output here we are getting there. Let me copy this program here. Then after that, I want to show another versions of output. No, if I execute one more time, output will be varied, but still synchronized block output only. I will show that one also. In our systems, we may get that output. All right, so now let me copy this program output here at present. Yeah, it's okay. Program is perfect. The output we are getting, that is perfect. Now I want to run this program once again. Now try to understand. Previously, what output we got there? Before synchronized block thread 1, before synchronized block thread 2, before synchronized block thread 3. Then after that 10 times inside the synchronized block thread 1, 10 times inside synchronized block thread 2, 10 times inside synchronized block thread 3. This output we are getting. Let me execute it once again. Yeah, now see this what we are getting now. Before synchronized block thread 3, thread 2 we are getting. Next one is what there? Inside synchronized block thread 3 we are getting or not? Then again what we are getting now? Before synchronized block thread 1 we are getting. Next one is what there? Inside synchronized block thread 1. Next one is what there? Inside synchronized block thread 2. Still it is the valid output. Why it is valid output now? Inside, just we have to put focus on what there? Inside the synchronized block. Once the thread 3 is entered inside the synchronized block, is there any other thread is interfering that thread 3? Got my point or not? But thread 1 is coming before synchronized block only, but not inside the synchronized block, in the middle of the thread 3 execution. So after completion of inside synchronized block thread 3 only, inside the synchronized block thread 1 we are getting, inside the synchronized block thread 2 we are getting. Execute one more time. Now see this one. Now we are getting perfect output. Yeah, now see this one. Before synchronized block thread 1, then immediately thread 1 is started synchronized block. All right, once it is in synchronized block, inside the synchronized block thread 1, any other thread is coming in the middle of the thread 1 inside the synchronized block? No other thread is coming here, but we are getting what there? Before synchronized block thread 2, before synchronized block thread 3. Means that, is that inside the synchronized block or before synchronized block? Before synchronized block only, but inside the synchronized block, how many threads are executing now? Only one thread is executing. After that only other thread is executing. Still this output is what there? Valid output only. Sir, got my point or not? Okay, fine. Right, so this is a clear cut analysis here. We can understand about like what there synchronized methods and synchronized block content here we are providing. Next one is after that, it's okay. Note I am telling to you, observe carefully. In Java applications, it is suggestible to avoid, synchronization. It is suggestible to avoid synchronization as much as possible. Why? Because synchronization follows sequential execution. It reduces the it increases the application execution time. It reduces the application performance. That's it. In Java applications, almost all it is suggestible. It is suggested to avoid synchronization as much as possible in Java applications. Why? Because synchronization follows sequential execution. It increases the application execution time. It reduces the application performance. Right, sir. Now this is the total story about like what their synchronization. With this thread safe resources, the topic is completed. Yes, sir. What topic is completed here? Thread safe resources, the topic is completed. Then after this, we need to go with what their inter-thread communication. We are using what their inter-thread communication, the next topic. Okay, that's it. Now my project is working fine, right? Yeah, still I have a doubt. Somebody else is playing with my projector now. Then almost two times we repaired that, that projector, but don't use that mechanisms there. If it is a case, if it is continuing no, then I have a solution for it. What is the solution now? I will take your mobile phones, all of your mobile phones now. Where is my sir? Doing, I think you stopped it right today. Then tomorrow onwards, keep your mobile phone in front of me now, on my table, right? Right. Otherwise, I will arrange one table there in outside. I will keep all of your mobile phones in outside only. Even if you are getting call from your girlfriend, nobody will. Otherwise, my classroom in charge will lift it. Sir is too busy inside the class. No, don't disturb sir. Like this message we are going to send. In Springboard, there is a concept like messaging. I can write a program to send message automatically to your call. Don't disturb unnecessarily. Stupid. You don't have any work. I'll give that message there to your girlfriend. Finish. Your life will be saved there itself. Yes. Right, sir. Now take some break and come back now. I'll go for advanced Java.